Okay folks, this video will deal with the test that was written in January now by the grade 11s, and that test was based on their grade 10 work. Okay, and it contains the problems that you guys had or common misconceptions during the exam. So let's see. The first question asked us to simplify, and there was 4 components to this question. Here we have a fraction, okay, with quite a lot of stuff at the top and the x minus a at the bottom. Notice that this is going to be for 6 marks. Okay, so this one is for 2 marks. It's another fraction, but there's exponential laws involved. Number 3, similar situation to number 2 with just a bit more in it, where the x's are in the bottom, the bottom there, the x were in the power. Okay, so x forms part of, as a placeholder for a number, if you want to think about it like that. Notice that that was for 4 marks. And then part D, we had to simplify an exponential expression where everything was multiplied by one another and the bases were not the same. Okay, so let's see what is the first thing that we notice about number A. Number A, we've got x minus 3a here. We've got 3a minus x. We would ideally like to have x minus 3a. So we can remove that as a common bracket. Now remember, if you change the signs in your brackets, you need to remove a negative, and that goes and lies in front of the bracket. Okay, so if we do that, I'm saying it again, we don't want 3a minus x, we want x minus 3a. So inside that bracket we needed to change the sign. That negative comes and lies in front of the a squared. Okay, now I have a common bracket, x minus 3a. What am I left with? I'm left with x squared minus a squared divided by x minus a. Again, look carefully. There was a x minus 3a, there was a 3a minus x. Ideally, I want to remove those two as a common bracket. To be able to do that, I need to change the sign in the bracket. In other words, whatever comes in front of the bracket is a negative. Now I can see beautiful x minus 3a. There's the difference of 2 squares, x minus a, x plus a. All of that was over x minus a. And look at how beautifully this now simplifies itself. My final result for the simplification of that fraction was x minus 3a multiplied by x plus a. Okay, for a good 6 marks. Now you get marks for changing that sign, you'll get marks for removing the common bracket, you'll get marks for identifying that this is the difference of squares, and then for factorizing it as such, and then a mark for losing the common factor that created in the numerator and the denominator, and then your final answer. Okay, let's see what happens in this question. This question is based on 2 exponential laws. The law that says a to the power m to the power n is the product of the 2 powers there, and then the law that says if I divide like bases, so a to the m divided by a to the n, the bases are like. All I need to do is I need to subtract their powers. So we're first gonna distribute or get rid of that bracket by law number 2. So we'll get a to the 3 multiplied by x is 3x. Then that would have been divided by a to the minus x. Now I'm going for the second law. If I divide like bases, all I need to do is subtract their powers. So I get a to the 3x, be careful, minus x, that's a negative x. Minus times a minus is a plus, and I end up with a to the 3x plus x is a to the 4x. Beautifully simplified for 2 marks. Okay, so you'll get a mark for the distribution there, and you'll get a mark for then applying the second law which brings you to 4x. Now let's look at number 3. Number 3, we're still simplifying. Now the biggest catch here is as follows. Look at where your brackets are. Your brackets are there. The square there needs to distribute to each one of those two things. Okay, so the 3 next needs to get squared, and 3 squared we all know is 9, not 6. It's not 3 times 2, it's 3 times 3. X to the power 3 to the power 2 again, it's raising an exponent to another exponent. You multiply those two to get x to the 6. That would have earned you 1 mark. The denominator, I'm multiplying like bases. If I multiply like bases, I add their powers. So that becomes x to the 2 plus 4, which is x to the 6. And then x to the 0 is 1. It can only be 1 if x is not 0. Okay? X to the 0 can only be 1 if x is not 0, because 0 to the 0 is indeed an indeterminate. Okay, so the x to the 6 and the x to the 6 are the same. We can cancel those two out because we're multiplying. We have 9 then plus 1, which gives us 10. And that was for 4 marks. Okay, so simple again. You apply your exponential law. The law that applied here to that distribution was a times b. Now let's say that's to the m. To the n becomes a to the n, the power goes to this base, and then those two powers multiply one another. Okay, the last one deals under simplification, deals with a lot of different bases and various powers over them. Every base is multiplied. There's no plus or minus between the bases. So our method is going to ask us to prime factorize each base. Now folks, here you make silly mistakes. You can make a silly mistake. So please keep everything in a bracket. This is 3 squared. Multiplied by the prime factors of 10 is 2 times 5. And that then is raised to the power x minus 2. We'll come back to that now. This here is 2 times by 3 to give 6. Outside the bracket x minus 4. Times 15 is 3 multiplied by 5 to the power of x. Now each power goes to every single base. You're not going to say this is 2 to the x times 5 to the minus 2. It's 2 to the whole power times 5 to the whole power. Don't make that mistake. Here again, it's the third time we use the same rule. So that will be 3 to the 2x multiplied by 2 to the x minus 2 multiplied by 5 to the x minus 2 divided by 2 to the x minus 4 multiplied by 3 to the power x minus 4 multiplied by 3 to the x multiplied by 5 to the x. Now remember, the power goes in its full entirety to each of those bases. Now I'm at a situation where I can see, hang on, there's a base of 3. There's 2x at the top. What do I have in the denominator? There's another 3 here, which I then take to the top by changing those signs. So minus x plus 4. There's another 3 to the x in the denominator. It goes to the top as minus x. Now 3, I've collected all its powers. Times 2. Now the power at the top is x minus 2. This x minus 4 goes up, becomes minus x plus 4. Okay, and that's it. That takes care of the 2. The 5 is x minus 2 minus the x from the denominator. Why can I do that? I can do that because I'm multiplying everything together. I can only start doing this if I have factors, which is what I have here. Okay, so let's see. 2x minus x is x minus another x. The x's are gone. I have 3 to the power of 4. The next one, x minus x is gone. I have 2 to the power of 4 minus 2 is 2 to the power 2. Here the x's go, and I have 5 to the minus 2. Okay, so this here is 27 times 3, which is 81, multiplied by 4, divided by the 25. So this here, 320 times that is 324, divided by a beautiful 25. Sorry, that was off the screen, but it's simple arithmetic. Now that was the first 4 questions on the paper, where you had to simplify. Make sure that you know your rules, folks, so that when we ask these questions, it's merely just a matter of applying those laws that you already know.